Good evening, everybody. This is Space Engineers Let's Play, uh, episode 32. And today I mentioned we are going to do a couple of quick redesigns on our industrial complex. Oh, actually need to lift this off first, because one of the redesigns we are going to do is moving the connector down to the bottom, or the other side, because I think we're technically going to call this the bottom. No fuel. Where did all the fuel go? There's fuel. Oh, I turned the reactors off. That's where the fuel went. Right, so we're clear of that. Grind it off. And move down to the other side. Our ship could shoot at these meteors, but I'm honestly just going to assume that they're not going to hit. One of these days that's going to be a dangerous assumption. But yeah, they're over there. We're okay. Okay. So that's the connector attached. The next thing I want to do is rotate this reactor. It's just pulling it right on in. Okay, we need to turn the conveyor off then. And grab it. Oh, inventory full. Those. And I want to face it this. Yeah, that'll work. Because the idea is we're going to put another backup reactor on the other conveyor port. Already pulled more uranium in. We're going to shut in all that. Alright, and then want to move this onto the connector that we just moved. So the rest of the plan after we get this reconnected is we are going to go ahead and build a programming block on our ship and then get started with some scripting. Got a bunch of plans for the script, but the focus for today is going to be on an oxygen indicator. It's not really something that you have to worry too much about as long as you're occasionally using the O2H2 generator. It will refill the cockpit with oxygen, but there is actually a finite amount of oxygen in here. But there's no indicator that I'm aware of that actually shows you how much. So I would like to have that and put that on one of our LCD screens in the cockpit. Now there are 4 LCD screens. One's going to be for that oxygen indicator. One is going to be for kind of a fuel power output. One's going to be for cargo, and then the other one's going to be like a detail display. So that one's going to be a little bit more involved and will definitely come last. That's kind of an awkward camera view there, because our camera is pretty much at the same level as the connector now because of the way we have the turrets and stuff arranged. But anyway, that'll work. Locked. So that is moved. It is now on the top of that cargo container. We're going to put another one next to it and another connector on that so that we can connect up 2 things to this. We only really have one that we need to worry about. We don't need to connect the construction module to this at this point. There's no real need for that, but we may in the future want to have that option. And this is going to go right down here. Like that. If we ever need to add additional scripting blocks, we've got 2 more spaces on the sides to do that. But this one's going to go right here. That's done. Now we're going to sit in here to actually do the work, so that we don't have to worry about suit energy or oxygen or anything like that while we're sitting in here. Programmable block. Edit. Alright, I am eventually going to use all of this stuff, at least hopefully. I would like to work on storage. I've never really used storage up to this point, but I think it will be important. But first we need to declare some variables. So my cockpit, main cockpit. I'm going to plan on editing some of this stuff, I think. No, I'm going to plan ahead. List my text panel, oxygen status is a new list. My text panels. But temporarily, at least, no, I'm going to do that. I'm not going to use the main variable for that. I'm just going to do that down here. It's going to be public void configure panels. My text panel. A lot of people like to do this work in Visual Studio. I've never set that up. It probably would be significantly easier because it's got IntelliSense and all that, but since setting it up is a little bit of work, I wanted to make this as accessible as possible and show you how to do it inside the scripting block itself. Update frequency. Oh, wow. I always forget how this actually is phrased, and I forgot to write this one down. Update type. Dot. Tick 100? Is that what it is? I don't think it is. I'm pretty sure that's wrong. Come on. Oh, it's runtime. Runtime.update frequency. And I think it's next 100. Runtime does not exist in the current context. Alright, I'm going to break down and look it up. Excuse me for just a moment. So there is API documentation on the internet. I will try to remember to put a link in the description because it is extremely helpful. It could definitely be better, don't get me wrong. The documentation is far from perfect, but it's definitely better than nothing. It is runtime. Oh, it's not camel case. Well, it's not camel case anyway because it's got a capital R, but this is runtime.update frequency. And this is not update type, this is also update frequency. That's not capitalized right either. Update 100 is what it is. Okay. Problem is I only ever write this line once for each script, so I never remember exactly how it is written. Update 100. There we go. That's just a warning that we're not using this variable. That's okay, we're going to. So what this is doing is this is making sure that this script runs every 100 ticks. Now we may eventually add additional ticks to this. We can run it every 1 tick, every 10 ticks, and every 100 ticks. And we will get a different update type here in the update source variable that calls into main. But for our initial setup, and I think in general for this particular use case, we can stick with just 100 ticks. It doesn't need to be updated frequently because it's going to be um, pretty steady overall. So we do that in the program method here, which is the constructor. This gets run once when the programming block first gets compiled and executed and saved, and then it doesn't run again after that. So this is all for like setup and configuration kind of stuff. So we will set that. That's the update frequency, and then we want to save the cockpit. Grid terminal system is how we access the blocks themselves, and then we want to get block with name cockpit. I think that's what it's called. Oh, we do need to cast it because the grid terminal system get block with name returns a grid terminal block. We need it to return a cockpit. But they're within the same class structure, so they can be cast. There we go. And I want to make sure I have that name right. Cockpit, yeah, it's just called cockpit. Good. So the first thing we need to do here is we need to figure out which panel's which, because there are 4 different panels and I don't know which one is on which index. So what we're going to do is main cockpit dot get surface is the name of the method. I know there's 4 and I know there's 0 indexed, so get surface 0. And that's just going to get it. It's not going to do anything with it, so we need to call configure panels on it. No, not yet. I want to save it because I want to. This is not the best way to do this necessarily, but this is temporary code. So we can get away with it. I'm just calling it T-panel, temporary panel. And this is just to make sure that it's in the right mode and everything, because right now they're all in script mode except for the except for the keyboard one, which is actually on no content, so that's not going to do anything. But we will want this in the long run to be able to do all this work for us, so I'm going to start working on this. So panel dot content type equals content type dot text and image. We can also set a font here, font size, color, background color, all that good stuff, and in good time we will. But for now we just want to make sure that it's displaying text and image so that when we do tPanel dot write text, this is index 0, it will actually display it. So that should be good. Cannot implicitly convert my text surface to my text panel. But I can cast it, so I'm just going to cast it. There we go. Hit OK on that. Object reference not set to an instance of an object. Okay. What did I do? Yes, it is. It's what I passed in. Oh, I think, yeah, this isn't actually a text panel. I think this is really just called a surface. I think. Maybe. This is why I try not to write code on camera, but I think this is useful from a tutorial standpoint. Hopefully you agree. Alright, no errors that time. Yeah, I didn't like the cast. Alright, so 1 is the center console, or 0. Index 0 is the center console there. If we do panel dot alignment, I think it's text alignment dot center, and panel dot font size equals 2.0f. Yep. There we go. So it got a little bit bigger and it got put in the center. So that's 0. And like I said, all this code is temporary. We are eventually going to just assume that we know this rather than having some nonsense to discover it. But we're just going to copy this block and paste it in here a few times. 2, 3, 4. So this is going to be for surface number 1, index 1, index 2, and index 3. T-panel is already defined. Okay, so this is because I'm declaring this variable 4 times. You only need to declare it once. So I will just remove these. And again, this is nasty. This is not how I'm going to keep this in the long run. This entire block of code is going to be removed, and we're just going to save the oxygen panel, or this one on the left, whichever one we figure out that to be, into the oxygen status list. These are going to be text surfaces, not panels. I'm pretty sure the LCD screens have text surfaces, so we can, or at least can be cast into a text surface. So even when we're using LCD panels additionally anywhere else on the ship, which we may or may not actually do, it'll be okay that these are text surfaces. But anyway, the main thing that we needed to fix there was we only needed to declare the variable once, and then we can just overwrite it for each panel. Alright, so the one on the left is 1, the one on the right is 2, and the bottom one there, which is the keyboard, is 3. So we know we need to save the oxygen panel as number 1. This is another reason why I like writing code in the scripting block itself in game, because it's a lot easier to go back and forth and check stuff as you incrementally develop stuff, and that's honestly the way that I do a lot of my development is okay, get this part to work. Okay, now get this part to work. Okay, now get this part to work. So oxygen status dot add main cockpit dot get surface 1. Is that how I want to do that? Now I'm passing in an entire list here instead of just one text surface. So I need to make some edits to our configure panels function to accommodate that. Because right now it's just expecting one. It actually needs to get a list. And then we need to loop through the list. There's only one at this point, so this is kind of silly, but it will make sense if we add more panels in the future or have multiple panels being configured at any point. I'd actually want to be able to customize some of this stuff. But I do want defaults. So instead of hard coding the alignment here, we will use the align variable, which is defaulted to center. And instead of hard coding the font size here, we will use the parameter, which again is defaulted to what we originally had it set to. If you set a parameter equal to something in the function declaration, that will be a default. So if you don't actually pass it in, it will be set for you. So you need to make sure that you do things in the order when you call them, and you need to have all your defaulted parameters at the end. So now we're not going to see any change because we didn't clear these other screens, but it didn't complain, and the right thing is there. Actually, oh, we didn't write anything at all. Now, for the same reason with configure panels, we want to have print panels be a list. So if we want to display anything to a panel, we can display it to all the panels of the same type. We want to set the default to true. So if we want to clear the screen first, we have to explicitly say false. But if we don't explicitly say, then it will just append to the screen. For each my text surface panel in panels panel dot write text. Text append. So this will write whatever text we pass in. It will append if we don't pass a variable or if we set it to true. It will clear the screen and write it if we set it to false. Okay, that worked, or that was correct anyway. Print panels oxygen status. But we do actually want to clear, so we'll pass in false as the append value. Now it says oxygen status, just like it's supposed to. Super. All right, so we've saved a reference to the cockpit. We have set up our oxygen status panels, and we printed the header. So now down here in the main method, and this is going to be run every 100 ticks, and I do not format my code blocks like this on separate lines, as you will have noticed from my function declarations. Be consistent. So in here, what we're going to do is we are going to have a, I think it's a float. Is main cockpit dot oxygen capacity. Make sure it actually is a float. Close enough. Float oxygen fill. Is the oxygen fill times the oxygen capacity out of the oxygen capacity I'm going to change this a little bit because I want to reuse a value. And if you're reusing values, it's better to do it once and save it than do it twice and have to do the math twice. Oh, actually, what am I doing? I could just use the fill ratio. I don't have to do it twice. Whatever. I may want to use it again. So these curly braces here, and it's kind of hard to see that they're curly braces in this editor, inside of a string with a $sign, string being text in quotes. The $sign in the front says that it should use interpolation, and everything in the curly braces will get run as code rather than saved into the string, and then it will be able to display like that. So what we're doing is we're getting the oxygen fill, which is the actual amount of oxygen, which will be the fill ratio times the capacity. Then we're showing the capacity, and then we're actually showing the fill ratio as a percentage. And the fill ratio is already the percentage. So what I was thinking earlier when I was talking about reusing values and doing math is that I wanted to do oxygen, actually do the math of oxygen fill divided by oxygen capacity, but that'll just be oxygen fill ratio again, so there's really no need for me to do that. So we do it like that, and then we do print panels, oxygen status, the string that we just generated, and this time we do want to append, so we don't need to pass that third parameter in. It does not contain it. definition for oxygen fill ratio. I thought I had that right. All right, back to the API documentation. I tried to actually write some of this stuff down ahead of time so I wouldn't have to go back and forth like this. But apparently I wrote something down incorrectly. So I apologize for that. Let me look this up and put the right value in. Oxygen filled ratio. That's even what I wrote down. Yeah. It would help if I actually read my own notes carefully. Go ahead and put it in throughout here just because it's more consistent and I'm more likely to remember it next time. Oxygen filled does not exist in the current context. I'm pretty sure it does because I just did it. It's right here. Except I spelled it wrong. Oxygen fill. Oxygen fill. There we go. Cannot convert from string to list. No, that's because I reused the variable name. That was a mistake. So this is going to be oxygen status. No, this is what I'm going to rename. Oxygen status panels. Yeah, so if you don't have a local variable, then it will go to the next highest scope to look for it. But if you do have a local variable, it will use that one. It's not going to use the one in the higher scope. So because I called this string the same thing as I called the panels, it got confused and it said you can't, like, this is a string, you can't call this a list. It's not a list. There we go. Oh, we need to do a line break because it's all showing up on one line. Oxygen status, line break. \n is the special character for a line break. No, and it's just appending the text over and over again. That's not what we want. So first of all, I need to move this because when I clear the screen, I need to rewrite this part. So we'll move this from the program method, from the instantiation method, down here to the main method. So this will get done every time, it'll clear it every time, and now this will update instead of appending a big long list of the oxygen capacity over and over again. There we go. So that is not going down at all. I'm not honestly entirely sure why, because there's no oxygen anywhere else, and the generators are off. So I don't know why that's not depleting. It should be. Oh, there we go. So yeah, it does deplete. It just depletes pretty slowly. And I think I want to pretty that up a little bit. I know we're spending a lot of time on this at this point, and it's probably getting kind of old, but this is the only thing that we're going to do for the scripting today. So if this was not interesting, I apologize. You don't have to watch it again. But I want to do the same sort of numerical formatting that I did over here with the percentage. This converts it to a 2 decimal point number and, rounds it appropriately. I also want to go ahead and put the percentage on the next line rather than at the end of this one. So we'll do a line break there. Then we'll do a toString M2 on that, and a toString N2 on that. And now this is starting to run off the side of the screen, and there's no scroll bar. So even when I'm, actually on here on the line, I can't actually see what was being typed. So in order to deal with that, I'm just going to break the string. This is another downside of working inside of the code editor. But we'll just do oxygen status plus equals. And this appends the string, basically, is what it's doing. It's not oxy status, it's oxygen status. M2 does not exist in the current context. What do you mean? Oh, I didn't do the interpolation. Got to do the $sign for the interpolation. Then everything in the curly braces is not being read as a string. Because what it was doing there is it was reading this quote as the end of the string. This is a wannabe variable name, and then this is a separate string. But because this is all inside of curly braces, the $sign will stop it from doing all that. There we go. So now it says oxygen status. It shows you the actual amount. And I'm going to add a unit onto that just because it'll look a little bit better, more professional and whatnot. So this is liters. There we go. 59.94 out of 60 liters, 99.90%. So there's our oxygen status, and we are going to make some improvements to this over the course of developing this script. In particular, I want to have it detect whether or not we are connected to a gas generator or an O2H2 generator. It's called a gas generator in game. If we are, then we want to see if we have ice either in the gas generator or in any sort of connected cargo, and if there is a legitimate conveyor connection between the gas generator and the cockpit, so that we can use the gas generated to refill the oxygen if the generator's turned on, and if we can use ice in the rest of the cargo to refill the gas generator. So that'll basically just be an indicator that says, this is your current oxygen, but if you turn on your gas generator, you'll get more, so you'll be all right. So that's basically just going to be a true-false thing, that all evaluates down after it checks all that, along the chain to say, there's more here. And we may actually even go further and put an indicator of exactly how much ice is in the cargo. I think, yeah, I'm going to do that. It's going to say how much ice is in cargo, or just say no ice. So if it says no ice, that's, when you run out, you're done. If you do have ice, on the other hand, it'll tell you how much. And you can get an indication of how long that'll last you then if you run out of oxygen in the cockpit, but just turn on your generators. And we'll see here, if I do turn on the generator, that refills. It takes a minute for it to update and come through the conveyor system and everything, but if you turn on the O2H2 generator, the oxygen status refills to 100%. And it does take a little bit for you to actually use it. Like, I was flying around here when I first came up, and I burned through all of my ice, converted it all to hydrogen, and was actually starting to run low on hydrogen. But as I was flying around here the first time, when I eventually had to go back down to the planet and drill up some more ice, I did actually start to run out of oxygen, like to the point where, because I had my helmet open, I started suffocating. So that is a thing. You can run out of oxygen in the cockpit. It takes a good while. I mean, you can see how long this took just to go down to 99.9%. So it takes a while to get to that point, but it can happen, and I'd rather know it when it's coming than have it sneak up on me. I mean, at this point, we've got 60 liters of oxygen that gets used exceptionally slowly. We've got 100 in our suit. We've got a 100% full oxygen bottle. So, I mean, it would take a very long time at this point for us to run out of oxygen, but it can happen. I did actually burn through the oxygen in the bottle as well, or at least started to. Was getting pretty close to. That's when I was like, all right, it's time to go back down. I wasn't recording any of this because it was, just tedious me flying from asteroid to asteroid trying to find something useful, in particular uranium. But, I did get to the point where I was down, I think, to like 30 or 40% oxygen in my suit with no bottle or anything like that. So, like, if I didn't turn around and head back to the planet, I would have started suffocating in space, and there wouldn't have been anything I can do about it. Like I would have respawned back at the survival kit, needed to jump in and try to get down to the planet and find my body or whatever. I mean, I would have been moving, so finding my body even wouldn't have been practical. So I would have needed to jump in and, get down to the planet at that point before I ran out of oxygen again. Um, in any case, that wouldn't have been fun. That would have been a bad time. So it's better that we've got this indicator now. We'll know when it's coming. We'll know when it's happening. We can make accommodations for it to be dealt with. Actually, I wasn't even looking for uranium at that point. I was still looking for ice. If I had ice, I wouldn't have had to worry about, you know, regenerating oxygen. But I couldn't even find ice, so I had to go back to the planet to find it because it's all over there and it's real easy to see from space. It's all the white parts. So yeah, we've got the oxygen status indicator working. In the next episode, we are going to work on power status. That's going to involve looping through the reactors, the hydrogen engines, and the batteries. Now, the hydrogen engines are a little bit fun because they are of the type IMI power producer, but they don't actually have a subtype configured in the API yet. So, like, you have to actually look at the power producer object itself and kind of determine from the value set on its properties whether or not it's a hydrogen engine. So we'll go through that. It also doesn't have an API for determining how much fuel is in it, so you actually have to read that off of the detailed info. Um, the detailed info, by the way, is this information here. Everything that shows up on this panel is detailed info. So we'll have to, parse through this and get these numbers to determine how much fuel is in the hydrogen engines. But because it's a power producer, there are APIs for the max output and the current output. So we'll use that. We'll also use that for the small reactors. Well, these small reactors, because we're going to only want to find the ones that are actually on grid. These are on a separate grid. And that's really easy to filter out. But so we're going to want to do that. You can see we got max output, current output. And then the batteries also have a max output, current output, but unlike the other power producers, battery blocks have stored power and input. So we'll also be looking at that. And that's basically going to be an indicator of our auxiliary power. So I mean, we'll know how much power we have based on what's turned on and based on what can be turned on, because currently the batteries are off. So it'll only show like, okay, currently used power is, so much. It'll show you what the potential power is for each type, each power type. So we'll have reactors, hydrogen, or nuclear hydrogen battery, and then we'll say, this is how much power we've got available based on what's currently turned on. This is how much power you've got available if you start turning on, if how much power you've got available but haven't used. Excuse me, if you turn everything else on. So that'll be how that is indicated. And we'll also have a notation for how much power is in battery storage, how much hydrogen is in storage, and how much uranium is in storage. So that's the plan for next time, is to do the power indication. And then after that, we'll do cargo. And then we might come back and start working on improvements. Although honestly, because of the way that the power panel needs to work, because it needs to find additional fuel that is available to either the reactor or to the hydrogen engines, because that's also going to have to show ice, because we can get more hydrogen from ice. And we may not get all this the next episode, just because it's starting to sound a little bit big for the scope there. But we will have the ability at that point to do the same thing for the oxygen status, because if we have to trace through the conveyor system to find ice for the O2 generators or the O2H2 generators, then we can also do it and use the same code for the oxygen status. So that is how we'll set that up. I'm also going to clean up the code a little bit. I'll probably do the code cleanup between episodes, because right now this is all in main. You don't want to put everything all in main. It gets messy if everything is all in main. You're going to have a very long main function. It's going to be impossible to read. So we'll break out some separate functions like we did here for configure panels and print panels. That will be like, update oxygen status. And like I said, I'm going to do that between episodes, because I mean, you're seeing how to do the coding. If you want to, figure out how to code cleanly and whatnot, then I think that's a little bit outside of scope for a YouTube tutorial. especially one that's supposed to be part of a Let's Play series. So anyway, subscribe to see all that coming. Likes, comments, verbal abuse is acceptable. If you have anything else you'd like to see, especially, let me know in the comments. I've kind of told you what my plan is for the immediate future here, but if there's anything else you want to see scripted or any questions you have about, the code that we're using here, please by all means feel free to comment. I am happy to help out as much as I can, or at least try to direct you to resources that are helpful to you. And like I said, I will put a link to the API documentation that I rely pretty heavily on in the description. So thanks very much. We'll see you next time. Bye.